coming here from Berkeley, and I want to just start off asking you to guess what this is, but I think you saw the auto-advancing slides already. But that's it's probably hard for you to see. That's dates on the bottom from like 2003 to 2014. Now, and how I got that was the IPython dev list has its archives hosted by Mailman, and so it's public data. You can then scrape and parse out with Python's mail library. And you can just count the number of emails sent in each day in the history of IPython development. And that was a little bit hard for me to interpret. So this is the point where I realized that I wish I knew a lot more about signal processing than I do. But I basically just smoothed over it. I took like for each day, here's like a 120-day window. What's the average number of emails being sent each day in that window, starting each day? So it's a little bit easier to read. You've got starting out about 1 or 2 emails per day in 2004, and now it's up to about 4 or 5. So I was looking at this data on the plane over here, and I happened to be sitting next to minRK from the IPython dev team, and said, well, so why is there this spike in traffic or participation on this mailing list? Over here he said, well, that's easy. That's because the IPython notebook was released at the end of 2011, and public development started earlier that year. And I thought, great. This is science. In particular, I'm a social scientist, and I'm gathering this data on these communities really in action. So that's a social system. I'm also a social scientist that I'm actually talking to my subjects, which is harder to do if you're a particle physicist. But I'm studying the scientists themselves, or really this community, or us, because I'm really passionate about this whole process of coming to know. But I've seen the future of science, and I'll tell you, it's computers. And so I really want to focus on the computational scientists, and I'm using quite a bit of computation myself. I've got a programming background. So I decided to call this, because this is a mouthful, I'm calling it reflexive data science. Just keeps it easy. My research question is how to create sustainable scientific software ecosystems, which is a question a lot of people are asking. The Moore and Sloan Foundations are asking it, so they're funding the Berkeley Institute for Data Science and the eScience Institute at UW. The NSF came out with a Dear Colleagues letter in April saying that it's now a national priority to know how to sustain these software ecosystems. And also, our open source communities, we've got an intrinsic interest in this matter. Before going to grad school, I was working in the geospatial web, the open geospatial web communities, and we ask these questions all the time. So I wanted to address this in my research, so I said, well, if it ain't broke, the SciPy community is really thriving. So how can that work that's already been happening and continues to happen be recognized and rewarded and imitated and continued over time? So my methods are evolving, but they're basically to pull the open data from the history of these projects, because these projects are always spinning off data, and then do some great data science on it, and then also talk to the people. Because every time I come up with a new chart, the next thing that happens is I have a conversation with somebody about it, and they tell me what it means to them, which is incredibly important for framing the research questions and moving forward. So it wouldn't be much of a study if it was just one mailing list. So I'm hoping to gather more and more data over time. This is 5 mailing lists, all hosted by the same Mailman instance on mail.scipy.org. And you can see they're quite different from each other. There's a bit of a decline in mailing list usage for a lot of the ones that used to have heavy traffic, like the NumPy discussion and the SciPy user list. But one possible explanation that people come up with is that GitHub and Stack Overflow might be where a lot of the discussions moved to, and those both started in 2008. So the point of that is not that I know with any certainty that that's the explanation, but that there's obviously a number of exogenous factors to this system. There's changing platforms, there's switching from, like the majority of the discussion from mailing lists to GitHub, for example. There's funding issues. I mean, if you want to create a sustainable software ecosystem, you could throw money at it forever. Obviously, it'd be nice to know how to do that more efficiently, but that's clearly going to be a feature. And then there's out-of-band talk. I mean, just take this conference and the connections you make here. All those are important to the scientific process. They're not going to be in this data set. On the other hand, there's plenty of endogenous things going on, like the information flow that happens when somebody sends an email to a mailing list or writes a ticket or, most importantly, submits a patch. And what's great about all this is that it's all time series data, so you can start using time series analysis methods on that. There's some good work on human timing. And also, you can really start to see people's social roles within the virtual community. There's work done on Usenet from like the 90s or so about, on certain lists, some people really just ask questions, some people really just answer them, some people get engaged in in-depth discussion. And when you start thinking, well, you can start looking at the social roles and then the social structure and how that interacts with these, technical objects that are also in the system. You can imagine, I hope with me, that you could get a map of the ecosystem structure and learn really what's going on. So I've been writing some software to do this work, and because I think humility is very important, I'm calling it Big Bang. And I don't know yet whether it's got a space in it or is camel-cased or is lower-cased, or maybe I should just shorten it to, we can talk about the name. But, and to be honest, right now it's a bunch of hacky scripts on GitHub today. Tomorrow, it'll be flawless and slick reproducible science. It's in the imagined future tomorrow. But I've got a plan, because this is actually my dissertation work, so I've committed to my committee on this. I'm going to start with the mailing list data, and then pull in the issue tracking data, maybe Stack Overflow stuff in the next phase. And finally, I want to look at the version control and source code itself, because one of the fascinating questions is how the community participation depends on the software dependencies of the technical artifacts that they work on. And then there's going to be a lot of time for writing and publishing, making beautiful IPython notebooks. Got big dreams. So please, I hope you'll keep this in mind and maybe pay attention to it moving forward. Pull requests are welcome, though. I hope this is a project that can get some community interest. I mean, as much as my academic advisors might not understand the value of a successful open source project, I certainly do, and it's something that I'm hoping to do. But back to email. They're kind of awkward as data sources because a lot of clients differ in how they implement the RFC spec for email. Mailman is the easiest to get at because they put some of their archives up on the web with a subset of the headers. And admins can get access to an MBox archive format, which has all the email and all the headers. So something I'm hoping to do is make friends with the people that are the admins of this list, or these lists. But SourceForge, they also have some web archives you can scrape, but they lose some of the headers, and the threading structure is then embedded in the user interface of the DOM structure of the page. So it's a bit more of a pain. And it seems like the MBoxes are even more hidden. Google Groups, as far as I can tell, it's like forget about it. If there's anybody that doesn't want you to crawl their UI, it's Google, and they make it really difficult. And the archives themselves are a paid admin feature. So if there's anything I could request is that if you start a new project in this space and you are interested in having your list being analyzed in this way that you do it with Mailman, if you don't want me creeping on your email list, use Google Groups. But email, if you can get it, is really interesting data. I wasn't part of this community at the time, relatively new, but some of you old-timers might remember this classic year 2000 email, the first email ever sent to the NumPy discussion list from Paul Dubois saying, "This is a test." And you'll notice that we're supposed to ignore it, for one. But disregarding that, email's time series data, which is wonderful. There's lots of ways to analyze time series data. It's not always a clean parse. I've seen a email dated at 2:30 and 73 seconds in the afternoon, and the parser chokes on that one. So I've been making use of the pandas missing data functionality a bit to deal with some of these edge cases. But something that's beautiful about email when it's done right is that they all have a unique message ID. That's in the RFC, original RFC spec for what email is. They got a unique ID, a globally unique ID. Magic. And what's great about that is the in reply to header also points to that ID. And so an email chain is really social network data that you can derive from these archives. And then what we did was we pulled it in with the mail library in Python, and then put it into NetworkX. And this is just a month picked at random, November 2011. But you can map out who's talking to who. And so arrowheads, width of the arrowheads, sort of squarish arrowheads, is a number of times somebody has addressed somebody else directly in a reply. And you can see on this dev list, there's quite a lively conversation. On the users list at the same time, it seems like much more of a question and answer format. It seems like the core team is basically doing one-off responses to people. SciPy dev at the same time, a bit more of a fragmented conversation, but the users list is hopping. And NumPy discussion is all over the map. And I want to see what's going on in all of them at once, and that's a huge mess. So that's totally illegible. But you can export it, and I don't know if any of you used Gephi or Gephi. It's spelled with a G, so it's one of those GIF things. Yeah, it's a great tool. You can use NetworkX, export that in a sort of common format. I use GEXF. It's like an XML format for graphs. Import it into NetworkX, and then use their layout tools, which are dynamic and GUI-ful. And what came out in this analysis is this is the names, which you might not be able to see. They're sized according to betweenness centrality, which is a centrality measure saying how many times does a node fall on the shortest path between other nodes. And so the question was, well, it's interesting. Like down here, this is like the IPython community. It's the one that I'm most familiar with, so that's why I'm pointing at it. And it really gets pulled back out of the data by this clustering algorithm. But this guy Robert Kern was, in this particular month, really the one kind of at the center of it all, kind of holding things together. And I asked my colleague Dave, well, who's that guy? And he said, oh, well, that's a great developer. No one will be surprised to hear that he was being like really core to this community at that time. And I thought, well, that's awesome, because if there's one thing that's nice to have when you're doing these methods, it's having your preliminary exploratory results get confirmed by domain knowledge, because that means, okay, betweenness centrality, what does that mean? Well, if it really does mean, well, this person was central to this community, if that interpretation is validated, then it's possible to extend that over time. It's possible to say, now I can say, oh, well, for every month, who was the most central person, and did that change? Because that's an interesting perspective. So it's just an example of, I really encourage you to use Gephi for anything. And it's really fun to play with, and you learn tons with it. All the algorithms, when you use them, have a citation to the paper that defines them. It's great. It's like a scholarly work in itself. But oh yeah, there's an ethics concern though. I mean, everyone's freaking out about data science ethics now because of this Facebook contagion study. I don't know if you heard, but. And someone joked earlier about how did this get past the IRB. Haven't yet filled out an IRB form, to be honest, because it's public data, and so it's technically okay, but still, people still feel issue about it. So one of the reasons why I'm here and talking it up is because I would like to hear people's concerns and figure out how to address them. Like, should I be coming up with a way to filter people out of the data set? And and I wanted to raise some of these questions that we'll talk about later in the panel later today. How much more time do I have?
Like a minute.
1 minute.
If we do like a quick question or.
Yeah, we can do questions.
What about Twitter? That seems to be, though, I mean, that's the way. So it seems to me that Twitter has suddenly become the way that people, a really important way that people find out about what's going on in this community suddenly. I don't know how suddenly that really is suddenly much more important than the mailing lists in a way.
It's a good question. Twitter data is harder to get at the archives of it. The REST API and the streaming API really get the most recent data, so you've got to set up like a crawler to get at it. And you have to kind of know what you're looking for before you do it. So, gosh, I mean, I've worked with some Twitter data before. I might just bail on that one and let that one be some follow-up work and focus on the internals of the communities, because I'm really interested in this kind of like collective cognition process that's going on in it. And from my experience on Twitter, there's less depth on it, probably to the character glance. We could just agree to disagree or just disagree more violently after the next question. Is there another question? This question? Yeah.
So I work for an interagency committee that often forms task teams. Would you see this analysis as being able to like pinpoint those people that are actually participating in the community to be on like a task team to make decisions? Like right now I feel like those teams are formed based on like some kind of inherent understanding that might actually map to what you've done, but more accurately might actually be found through the email or a listserv or something like that. Do you know what I mean? Have you thought about that, or is that your goal, or what?
I think I'm missing a little bit of the context on.
Yeah, sorry.
Yeah, no, please.
So I staff like an interagency ocean observing committee, and some of the things are like we do a task team on developing a national modeling strategy, and right now we find people for that team by kind of like your own knowledge of who is involved in that in the regions and stuff like that. But there's no actual analysis that goes into that might be as rigorous as what you've done through a listserv, say. Have you thought of applying, or is that your goal to like kind of create these networks and identify key people? And
so I hadn't heard that use case before. Absolutely. The sort of thing. So the reason why I want to implement this as a software package is so that other people can do similar kinds of analysis on, because there's tons of listservs, you know. So there's some people in my department who are interested in like internet standards bodies. Oceanography research is not a use case I considered, but I'd love to hear more about that use case, and if there's particular like things you're interested in detecting, you could file a ticket, submit a pull request. All that's great. So.
All right, a round of applause for my homie from the D Lab.